We're going to start off this video with an example. And this example actually draws from what happened on the previous video, which is that we had to find a chart of key values for this particular equation. And so this part here, if you wanted to see that, go back to the previous video and watch it. From here, what we need to do in order to graph the function is that we need to plot these points. And the trajectory for where we're going is that once we plot this example, we're going to then work backwards and think about what we can learn in general about how to graph these things. So here we go. Let's go ahead and plot our coordinate grid. We can see that we have denominators of 6 everywhere. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, and so on. So each one of those intervals corresponds to a pi over 6. And I've labeled these two right here just because this is 1/2 and that's 1 pi. You can label whichever ones you want. You can label all of them. Doesn't really make much difference here. What we need to do from here is actually start plotting these points. Now for each input value, for these key values, we have a y value. So the y value is either 1, 3, or -1. And we just need to plot them. So 3 pi over 6, 1, 4 pi over 6, 3, so 4 pi over 6, 3, 5 pi over 6, 1, 6 pi over 6, -1, 7 pi over 6, 1. And this gives us the graph. Now when we graph this, there are a couple things that we ought to do, which is that we ought to fill in this midline. And this is just visually to help put all the pieces together. If you wanted to, you could also graph sort of a line that marks the top and marks the bottom across like this, just to sort of show the range of values that this takes, so that also that lines up with these over here. Less necessary, but it can be helpful. And another thing we can do is that the graph of the function is not limited to this interval, right? It's a periodic function, it means it's going to repeat this in both sides. And so we might as well continue backwards, so going here to the low value, to the mid value, to the high value, like this, and then going forward, high, mid, low, and so on. Right? And this is the graph of the function. Now there are a couple of things we want to talk about when we get to here, which is how can we understand all the bits and pieces of this equation by looking at this graph? Because what that will do is it'll give us another way to more quickly create the graph. Well, I mean, we'll still need to know these coordinates, but it'll give us a quicker way to look at this graph and to sort of think about it, and it will actually help us go backwards from the graph to the equation. So what do we have? Well, we have this +1 right here, right? Remember that +1 corresponds to the vertical shift, and that's where this midline is, right here, y = 1. So that part we can graph right away by looking at this. The next thing we can look at is we can look at the starting point, pi over 2. So the pi over 2 value, which is right here, this is the start of the quote-unquote first cycle of the function. Now it's the first cycle in the sense that it's the first relative to the sine function, not relative to the axis. But what it says, what you do is you think about this right here. The sine function starts off going up and coming down and coming back up again, starting from the midpoint. So you can see that that behavior is happening right here. So this right here, we might call it the fundamental cycle, or the fundamental period of the function. And so this right here is that first period. And we can see that it starts at pi over 2. Where does it end? Well, it ends at the first period, at the end of the first period. That period is 2 pi over b, which in this case is 2 pi over 3. Right? And if you add pi over 2 plus 2 pi over 3, you will get 7 pi over 6. So this is matching up with that as well. So that takes care of this part. And right here, this corresponds to the vertical stretching. So instead of going up and down between with an amplitude of 1, the amplitude is 2 from this right here. And so we can also put together this graph by thinking about these parts and then use that to help put together the chart of key values. The important thing is that you have to be able to make both of them work, and they must match up with each other. So here's another example. Graph y equals negative cosine of 2 times t minus pi plus 2. And in this case, we're going to go sketch the graph first and then create the chart of key values. In the end, for my classes, the way I teach this, I really want you to know the locations of those key values. You can either do it by plotting the points on the graph itself or by creating a chart at the end. It doesn't matter. The point is that you need to be able to have that information. So let's go ahead and get started here. Here's our coordinate grid. What can we read about the graph based on this equation right here? Well, the first thing is that the midline is going to be at y = 2. So we'll put that in. This is y = 2. the next thing we see is that we're going to start at pi. Now here's where I like to think through things before writing things down, because I want to make sure I get the spacing right on this axis. It starts at pi, but then we also have to think about the period. So let's work at the period. The period is going to be 2 pi over 2, 2 pi over b, b is equal to 2, which is going to be pi, right? And so we know that the period is going to be pi, which means that the quarter period is going to be pi over 4. The reason why this value is important is because this tells me what my spacing along the x-axis needs to be. So I'm starting at pi, but my spacings are going to be at pi over 4. So 1, 2, 3, 4. That's 4 pi over 4, which is the same as pi. 1, 2, 3, 4. It's 8 pi over 4. Okay. So I know I'm going to be starting here. So here's going to be the start of my period. And then the end of my period is going to be pi later, which is going to be right here. 4 of those quarter periods later. 1, 2, 3, 4. And now we need to think about the shape of the graph. What is the shape of the graph going to be? Well, it's going to be a cosine graph, except it's going to be flipped over. So you might remember that the cosine starts at 1 and goes down and comes up. This negative sign takes that and flips it over. So it's going to start from below and go up and come back down again. And since this is a -1, we know that's going to go plus or minus 1 around the midline. So this is going to be 1, and that's going to be 3. So it's going to start down here at -1, go to 0, then go to 3, go to 0, go to 1. It's going to have that shape. And then this shape is going to repeat every pi. So in fact, this one works out nicely because I can quickly plot those points in so I can trace it more correctly. And then same thing going forward, right? So we've been able to sketch this graph, and because of how we've done this, because we've already worked out the quarter period and sort of all the rest of the bits and pieces, we can actually see what the key values are going to be. Again, we can write it as a chart, or you can just make sure you explicitly label the points as we go. Our key values, 1, 2, 3, 4, and 5. The t values we have, well, this is the first one, that's going to be pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2. You could also leave these with a denominator of 4. It makes no difference. And then the values go from 1, 2, 3 to 1. 1, 2, 3, 2, 1. So this is what I would consider to be a complete graph of this function. We've sketched it. We've shown the midline. We've shown the start and the end of the first period. We have all the key values listed down here. This is what I would expect to see for a complete presentation, or at least all these different components as part of your complete presentation.